All right, we're going to take a look at a couple more solving exponential equations. Same steps as yesterday. We make the bases the same, set the exponents equal to each other, and then solve for the variable. These are just going to be a little bit more complicated. So 1/5 to the 3x plus 1 is equal to 25. So first of all, we need to decide on a base to use. So on the left side, I have a base of 1/5. On the right side, I have a base of 25. Okay, now these are going to be a little bit more complicated because you're going to have fractions. Okay, now just keep in mind the way that you make a fraction is by using a negative exponent. Okay, so we can use a base of 5 for both of these because 5 to the first power is 5, but 5 to the negative first power is 1/5. So this can be expressed as 5 to the negative 1, and then the right side, 5 times 5, which is 25. So I can use 5 as a base for both of these. So for the left side, I have 5 to the negative 1 power, to the 3x plus 1, and the right side, I have 5 squared. So we have to use power of a power rule, so that negative 1 gets multiplied by 3x plus 1 on the left side, which of course means we're going to have to use the distributive property. So we end up with 5 to the negative 3x, make sure that looks like a negative sign, minus 1 is equal to 5 squared. And now we have successfully made the bases into the same number, which of course means that now the exponents can be set equal to each other. Negative 3x minus 1 is equal to 2. We can solve this for x. It's a two-step equation. Negative 3x is equal to 3. Divide by negative 3, and we get x is equal to negative 1. And that is the solution to my problem here. Whoops. Number 2, we have 3 to the 2x plus 4 equals 1/9 to the x minus 5. We'll start by identifying a base that we can use for both sides. I'm going to try to see if 3 works. I know that 3 works for the left side because 3 to the first power equals 3, so I don't really have to do anything to the left side. The right side is a fraction. So we're going to first try to get 9. So 3 squared, 3 times 3, which is 9. Okay, which means 3 to the negative 2 would be 1/3 times 1/3, which is 1/9. Okay, so we want 3 to the negative second power for this one. So we have 3 to the 2x plus 4, and we have 3 to the negative 2 and the x minus 5 power. So the left side's fine. The right side, that negative 2, is going to get multiplied by x minus 5, which of course means use the distributive property because it needs to get multiplied by both of them. So 3 to the 2x plus 4 equals 3 to the negative 2x plus 10. All right, mission accomplished. The bases are now the same, which means we can take the exponents and set them equal to each other. 2x plus 4 equals negative 2x plus 10. All right, so first we get the variables on the same side. I'm going to get them on the left side, which means I need to add 2x to move it from the right side to the left side. So 4x plus 4 is equal to 10, minus 4 to move that 4 over. 4x is equal to 6. Divide by 4, which will isolate the x. So x is equal to 6/4, which reduces to, this is 2 times 3 and 2 times 2. So it reduces to 3/2. So 3/2 is our solution. to number 2. Oh, looks like those were the only 2 examples we had for day 2. Homework page 94, 1 through 6, and number 19.